I'm Ahmed Daud, and in this session, we are going to discuss recall and precision. So, in the last session, we have discussed accuracy and confusion metrics, and we have seen that accuracy is not always a good measure to evaluate some model. Then we have seen confusion metrics, and confusion metric is not such a measure, and it cannot give you a single score like accuracy was giving. It is just the way of presenting the values, how much or how many values or how many number of samples are true predicted by the model and false predicted by the model. Or you can say confusion metric is the way of representation of model's predictions. Okay, how many model has done how many true predictions and how many predictions are done are the wrong predictions by the model. Okay, you can visualize the values in that way. Okay, so confusion matrix is not giving you a single score to evaluate to assess the model, how much your model is good. So in today's session, we will see recall, precision, and the third one, F1 score. So we will continue the example, the last example that we have discussed, where the accuracy was failing to evaluate the model. So here, first of all, what is recall? So before that, we have discussed that according to the accuracy is giving us here 80% score. Okay, in the case of that dumb model. Okay, in the case of dumb model. Okay, so now how recall can assess the model in more precise way, in more good manner. So what is recall actually? Recall is how many predictions are or how many uh, out of all the positive samples in our data set, how many samples are out of all positive samples, how many samples are predicted as a positive by your model. Or in other words, you can say ratio of positive instances that are correctly classified by your classifier. Okay, called as recall. Recall also sometimes can be called as true positive rate, and sometimes you will see that sensitive also can be used for the name of recall. Okay, so these terms are simultaneously people are using: recall, true positive rate, and sensitivity. So out of all the predictions, out of all the positive instances you have in your data, how many you have positive instances? True positive and false negative. You will see your confusion matrix here, predictions on this axis and actual values you have on this axis. Okay, so here these are the number of positive instances we have in our data. Okay, so this will be considered as a false negative and this will be considered as a true positive. Okay, so if you will add true positive plus false negative, it will give you all positive instances. Okay, all positive instances in our data set that we are using to evaluate our model, to assess our model. Okay, usually we are using a test data set. Okay, so here how many samples are predicted as a true positive out of all positive instances? This is actually the recall. Okay, how many samples are predicted or predicted as a positive, as a positive by the model out of all the positive instances, or you can say correctly classified. So this is the formula for the recall: true positive divided by true positive plus false negative. Okay, so according to that, if we will see here how many this model has predicted as a true positive. So there is a zero prediction as a positive. So true positive will be 0. And how many your model has predicted here negatives but false. So there are two negatives at this place, three fifth at this place, this one and this one. These are the predicted as a negative, but actually these are false. So there are two. So recall will be 0 divided by 0 plus 2, which will be 0. Here you can see. Here you can see your recall is 0. It means your classifier has 0% score, 0% recall score. By the recall, you can judge your classifier that how bad is your classifier. Accuracy is saying 80%, giving you 80% score, and recall is giving you the 0% score for the dumb model. You got an idea that how good is recall to use when we have these type of scenarios when our accuracy is not giving you a good measure. Okay, so we usually use recall as a measure. Okay, so it is clearly 0% score is clearly explaining that our model is dumb. Okay, or we have very bad model here. Okay, but now the story will not end. The recall is not always a good score. Okay, we will see the case where recall is not a good score. Okay, now consider a case when we have our model is predicting all the values as a positive. Means here you have a positive classifier. It is also a dumb model. It is also a dumb model. Okay, it is also a dumb model, and whichever sample you will pass to that model, to that classifier, it will classify as a one class. So what will be the score of recall when it will classify all the samples as a recall? So here you will see how many are true positives here. So first of all, one, two, three, four, fifth, this one and this one. These are the predicted by the model as a positive, and these are the positive. So these will be considered as a true positive. Okay. So how many samples are predicted by the model as a negative? Okay. There is 0 sample that is predicted by the model as a negative, 0 sample. And how many false positives you have here? There are 8 samples that are predicted by the model as a positive, but these are actually not. Okay, but false positive measure or false positive value is not in the formula of our recall. When you will use the recall formula, according to the recall formula, how many you have done the true, how many true positives you have to, how many you have false negatives, will have 0 false negative, because your model has not predicted any value as a negative, so it will be 0. So your score will be 1, or means 100%. Here your recall is saying that this model is, according to recall, is very good model, or very good classifier. But actually you have seen that it's also dumb. It's also dumb. Okay, so you got an idea that single recall you cannot use here. You should have some other measure that can resolve the problem that we are facing here. Okay, so we will go towards the precision. This will be the another measure that we will discuss now. So precision uh, is, you can say, the accuracy of the positive predictions, or in other words, the true predictions out of all the positive predictions by your model. Okay, like in the case of we were having here, This is true negative and this is negative but false. In the case of recall, we are considering just these parameters or these values. Okay, according to the recall, we are just considering the type 2 errors. Okay, this is the formula of recall: true positive plus false negative. We are considering how many predictions or how many out of all positive instances, how many our model has predicted as a positive. Okay, or our model has correctly classified out of all positive instances. Okay, we are just considering the type 1 error here, or sorry, type 2 error. Type 2 error here, you can see. Okay, but how precision work? Precision say that how precision will be calculated in this way: how many predictions, how many positive predictions are correct out of all the positive predictions by your model. Okay, your model has predicted these samples as a positive. Okay, as a positive. These are the positive predictions by your model. So precision will be out of all the positive predictions, how many are correct, how many are correct, or correct, you can say, or how many are true. Okay, your recall will be this one. Okay, this is the concept behind the formula, and the formula will become uh, here you can generate formula from here. How out of all the positive predictions by your model, out of all positive predictions, these are the total predictions, total positive prediction by your model, how many predictions are correct. So there are these, this will be the formula. Here you are considering the type 1 error. Okay, in the precision you are considering the type 1 error, but in the case of recall you are considering the type 2 error. So when you will calculate the precision for that model, here you can see. Okay, so if you will calculate the precision for this model, for this dumb model, which is a positive classifier, it's a very dumb model. Here you can write here dumb model. So according to precision, how many true positives here? Just two true positives. And how many false positives you have? 8 here. And here you will have 2 over 10, and it will become 0.2, or you can say 20%. Now recall is saying that this model, this dumb model, according to recall, this dumb model is uh, recall is saying that this model is good. Okay, but precision, according to precision, this model is bad. Is bad. Okay, because it is giving, precision is giving 20% score here. Okay, so you can get an idea. Recall, you cannot use only recall in all the cases, you have to use precision also. Okay, now precision is not always a good measure. Okay, you have to use both recall and precision in all the cases. Okay, you can also dodge the precision. In which way you can dodge the precision? If you will see the formula of this, the formula of the precision, you can get an idea. It is just considering the type 1 error. If you can dodge the type 2 error, if you have very high type 2 error, it will not get. Okay, you can see here, let's say uh, we have a model that will give just one true positive prediction, just one. Let's say we have this test data set in which we have actual 100 samples are zero, 100 samples are zero,
and 50 samples are 1. Okay, so you have used a model or classifier. Here you have used a classifier which has done just one, which has just done one prediction as a 1. Okay, it has classified just one sample as a positive and 149 samples as a negative. But the sample that it has classified as a positive, it is actually positive, it is true positive. So here you will see your true positive will be 1, your true positive will be 1 here, and your false positive will be 0, because you have not done any wrong prediction regarding the positive intent instance. Okay, you have your model has not predicted any instance as a positive, but it is not. Your model has just predicted one sample as a positive, and it was also. So how many you have done false negatives, and how many your classifier has predicted as a true negatives. Okay, so out of 140, 100 will be true negative, and 49 will be false negative. Okay, now you can see that here your type 2 error is your type 2 error is very high, your type 1 error is very low here. Okay, when you will use the precision formula, and precision, according to precision, true positive divided by true positive plus false positive. So according to this, 1 over 1 plus 0, and it will give you 100% accuracy. You have seen that your model has done just one prediction as a true prediction, but precision is saying that this model is very good, although it is having a lot number of type 2 errors. According to the recall, if you will calculate the recall for the same case, according to the recall, it will be true positive divided by true positive plus false negative, and here 1 over 1 plus 49. Yep, and it will be 1 over 50, and what it will become here? Yeah, it will be just 2%, 0.02, or you can say just 2%. Your recall is saying that this model is uh, just it is giving 2% score, means your recall is saying here this model is very bad, but recall is saying this model is very good, which has done just one true prediction. Okay, now you cannot use precision and recall separately, and you cannot or you will not be satisfied just by having high precision score, or in the case when you have just high recall score, you should have both scores, or you should have considered both scores, because recall consider just the type 2 score, and precision is considering just the type 1 score. In the formula you can see, okay, in the precision formula you are just considering type 1 score. So you have both scores, precision and recall, and on the basis of precision and recall you can you can say if your model is giving a very high precision, some person is will come to you and will say that his model is giving a 90% precision. So you should ask him that at which recall your model is giving 90% accuracy. Okay, so you should use precision and recall both measures when you are evaluating your classifier. Okay, so here we will discuss some cases. So precision and recall. When you have no compromise on the false positives, then you should have precision score. You should have high priority for the precision. Okay, let's say for the cases when you have no compromise on the false positives. Let's say you have a classifier which has to detect which has to detect safer videos for the kids. So if this classifier will detect some videos as a negative, means it detect that these videos are not safer for kids, but these are actually safe, so this will become false negative. So if your this classifier will predict some videos as a safer for the kids, but these are actually not. So this error is more dangerous as compared to this error in that case. Okay, so here you will care more about the false positives, and you want that your false positive should be minimum as much as possible, so you will consider precision. And sometimes it's also in the requirement of our problem that we have in some cases, or when we are doing some project we have a problem, and in the problem we have a task that we need like a 80% or 95% precision. Okay, but it does not mean that 95% precision at 0% recall. We should have recall also. Okay, it's this scenario will be the same, that if we are caring about the false positive, it does not mean that false negative should be very high. Okay, or false negative will be very high, we are satisfied, we will not be satisfied. We should have false positive as much as small, and false negative should also be small, but we are caring more about the false positives. Okay, in the other case, when we have no compromise on the false negatives, okay, then we will give the high priority of the recall score. We say that we should have high recall score. Let's say in the scenarios when let's say you're a classifier. Here you have a classifier which has to detect shoplifters on surveillance images. So if your classifier will detect some persons as a shoplifter, means positive, but these are actually not. And if your this classifier will detect some persons as not a shoplifter, but these are actually, means false negative. So this will be more dangerous than this in our case. In that case. So here you will care more about the false negatives as compared to false positives. So you will consider recall score as a high. Okay. So sometimes it is mentioned in the requirement this amount of recall we want. Like we want 80% recall. We want 90% recall. We have in our requirement. Then we have to achieve our 90% recall, and also with the highest precision. Okay, in the same way, sometimes we have in the problem statement that we can't compromise on the false positives, and we should have high precision, like we want zero false predictions, false positives. Okay, in that case we will have a high precision like 95% precision, and this will be our target by and this is also in the requirement of our project. So we will achieve 95% precision, and by having highest recall score also. Okay, so this will depend on the project of which score we want there. Okay, so if the case when precision and recall both are equally important, when we cannot compromise on both errors, type 1 and type 2 errors, then what we should do? Okay, either we have to use both scores, or either we have some other measure. So here the story of F1 score will start. Okay, if we care for the precision, or in other words, if we are we cannot compromise on both errors, false positives and false negatives, no compromise on both false positive and false negatives, then we can use F1 score. Okay, so it is often convenient to combine precision and recall into a single metric called F1 score. In particular, if you need a simple way to compare two classifiers, the F1 score is a harmonic mean of precision and recall. Okay, so F1 score is a harmonic mean. If you know about the some means, harmonic mean, geometric mean, arithmetic mean, then you will have an idea about the harmonic mean. If you don't have, it's not a big deal. Okay, the formula of F1 is simply this one. F1 2 into precision into recall divided by precision plus recall. Now F1 score will be high in that case. Here you will have a formula of F1 and we can discuss this formula. Precision into recall divided by precision into, oh sorry, plus recall. Okay, so if you have both precision and recall high, then F1 will be high. Okay, so if precision and recall both will high, then F1 score will be high. Okay, otherwise it will be not high. It means that if you have high precision but low recall, then F1 score will be low. Okay, let's say you have high precision, let's say 0.9, and you have very low recall like a 0.2, let's say, and it will be here 0.9 plus 0.2, and it will become, we will see here,
0.33%. Here you can say as your precision is very high here, precision is very high, but your recall is low, your F1 score is also low. Okay, recall your F1 score will be high in that case when you have both precision and recall are having high. Let's say you have a high. This is the just the ideal case. We always not have like this. If you have both precision and recall as a one, means 100% accuracy of both. So it will become, in that case it will become one, or you can say 100%. Okay, so in that case, you can see your F1 is 100% when both precision and recall are high. This is the nature of formula of F1, or you can say it's also nature of harmonic mean, that when both values will be high, then the F1 score will be high. So if both errors, type 1 and type 2 errors are both equally important, and you cannot compromise on both, okay? So there is not such type of scenario that we are discussing here. Okay, so both are equally important, and you cannot compromise on both. So then you can use F1 score to evaluate your model. How good is your model? And if you have to you cannot compromise on false positives, then you can use precision as a high priority. And if you cannot compromise on false negative, then recall will be your high priority. And it's also depend on the problem statement or the scenario or the requirement of a project, how much precision or how much recall or how much F1 score we want. Okay. Okay, here the same the data we have here, true values. Here we have predictions, and here we have probabilities for the class one. So if we want to calculate the scores of recall score or precision score or F1 score, we can calculate here directly by the sklearn. And if you want to code it to play with these formulas, you can do. It's not a big deal. Okay, so here. If I will show you here, for the recall and precision score, you can directly import from the sklearn.matrix, and here will be F1 score should also be here. Yeah, F1 score should will be in the below section. Yeah, here it will be. So you can import all of them. F1 score, F1 score, precision score, and recall score from the sklearn.matrix. Okay.
and then you can simply use here recall score, your true values, and your predictions. It will calculate all the confusion metric and the and by using formula it will give you the recall score. Here the recall score is 16%. If you will calculate the precision score, you can directly use the precision score by sklearn. It will give you here 0.38. If you want to use calculate F1 score, you can calculate F1 score and you just pass true values and the predictions. It will calculate the precision and recall first, and then it will, by using the formula of F1 score, taking the harmonic mean of precision and recall, it will calculate the F1 score 0.23. Okay, this is the provided by sklearn. So if you want to do calculate the F1 score by yourself, it's just the same. Let's say 2 into precision into recall, precision into recall. There will be precision plus recall, and here you will pass the values like this is the precision recall, 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 and here will be the values of precision, precision, and precision, and it will give you 0.230. Okay, it's up to you. You can do it by yourself, or you can use the function provided by the sklearn. Okay, so I hope you have learned a lot in today's session. So we have discussed recall, precision, and F1 score. These are very important metrics, and uh, we are evaluating our models in almost all the cases, and in the project scenarios, in the problem statements. We are using these measures to evaluate our binary classifier. So in the coming session, we will see some more measures and some we will analyze our errors or our scores from different angles. So for now, thank you.